This is chapter 5, problem number 1. The lucky number for this problem is 7. All right, so let's look at the question. You have a beam over here. Okay, so with this type of connection, that means you have a force can go in both the x and the y direction. Okay. With this ball over here, you can only have a reaction that is a normal force. You do not have any force in the x direction as is freely to move left and right. You see a blue arrow at the end. Let's forget about this arrow for the moment. Okay. In fact, this is called a free vector. It's a free moment. All right, so remember what our magical formula is? The torque that is equal to x times force in the y direction minus y times force in the x direction. Okay, so let's put this one as our pivot. Forget about the blue arrow here now. Okay, all right. This is a couple moment. So over here, you have 500. So what is the x and y component? The x component of this one, x component, it is 3 divided by 5 times 500. So that is equal to 300 Newton or pound. Okay. So the y, Fy, that is equal to 4 divided by 5 times 500, so that is 400. So we are going to plug into this formula and see what the total moment is. The total moment, since this is at equilibrium, so the total moment, sum of the moment should be equal to 0. So the sum of the moment that is equal to, plug into this formula, x over here is 5. So 5 times f of y, so that's the magnitude is 400, but it's going down, so it's minus 400 minus y is 0, and 0 times 5, so that's 0. So the other one is, so this one is going to make it, it should be negative because this force is going to make it clockwise. The other one is going to balance it. It's going to make it counterclockwise. So it will be equal to the force over here. So let's call it FB, the force at point B, times the length, that's 10 feet. Okay, so we add this to it. So that should be equal to 0 because it's at equilibrium. So we have 0 equal to this. So 10 times FB, that will be equal to, move this to the other side, it will be 2000. So FB will be equal to 200. That is assuming that the couple moment does not exist. If this is 200 going up, okay, so the sum of the forces should be add up to be 0. So a force going up, a force going down, let's look at this. So the force going down is 400. So 400 going down, 200 going up, and therefore the reaction force at point A over here would be 400 minus 200. So that is 200 going up. So let's look at the reaction at point A going in the x direction. So going to the right, it is 300. That means going to the left must be negative 300. That is only assuming that the couple moment does not exist.